Welcome back. And now it's time to code your own neural network in pure Python. No libraries, no magic functions, just implementing the pure internals to build your intuition. All our code is on GitHub. Just go to github.com/thinkingmachine/deep-learning-workshop and get all the exercises. Don't just watch this video. You really do have to download this notebook, which is pretty well annotated. And don't just read it. Retype it, run it, change some elements. Make sure you develop a good sense of how it all works. I am going to just spend 2 minutes quickly introducing this to you, and after that, go forth and code. So what we're doing here is we're generating for you a nice spiral training data set, which is not linearly separable. We demonstrate how to train a linear classifier, wx plus b, on this data set. So that happens here. We have some hyperparameters, the learning rate, regularization, and we can compute the scores, normalized softmax scores, correct log probs, so the probabilities of the correct classes. This is how you would update the parameters in order to decrease loss, and that runs as a nice loop. So here's just the pure code for the linear softmax classifier. It more or less converges to a loss of around 0.78 after 150 iterations, which really not that great. This is a visualization of the decision boundaries that the linear classifier can come up with. Kind of makes sense, kind of looks like the Philippine flag, but really just limited by its nature. So let's look and see at how a two-layer neural network could do better. We're just going to add a single hidden layer here. Remember, that means adding one set of non-linearities. We're using a ReLU activation function here, and see how the hidden layer passes the scores of the original layer, the linear layer, into the hidden layer with that max 0 times x activation function. Loss computation and score computation really remains the same. You just have to remember to chain the back propagation all the way back up. And so here's the full code for that. Again, pretty well annotated. Mess with everything. Change up the parameters, change up the hyperparameters. Maybe change the number of hidden layers if you wish. Change the activation function from ReLU to sigmoid and see what happens when you do that. And this converges much more nicely after a couple thousand iterations, a loss of 0.25. Drastic improvement over the linear model. Training accuracy dramatically better. Let's just visualize this. Much nicer split. And remember that we didn't have to feed in any additional features. This data set is just operating off of two features, which are the x and y positions of each data point in this two-dimensional space. We didn't need to build in any features about its position in n-dimensional space. Really was a very nice improvement you can do with just adding one layer. And I think it's a nice demonstration of how nicely neural networks can work. Now, go and try it.